Rob Allen, and we're here to talk about Serverless PHP. And what I'm going to do today is I'm going to take you through what Serverless is, how it works, and then look at how to build an application in PHP that runs on a serverless platform. So let's get started. Serverless, what is it? This is a description from Paul Johnson. A serverless solution is one that costs you nothing to run if nobody is using it, excluding data storage costs. This makes total sense because the whole point is that the system is always available, but it's not always on. So when your servers are idle, they are not being paid for. They're not running, they're not doing any compute work, you are not paying for them. You'll always pay for storage. So you have some stuff stored in S3, store stuff in DynamoDB, wherever, you're going to be paying for that. It's one of the as a service things. There's quite a few of them. Storage as a service is fairly familiar to all of us now. We've probably got stuff on S3 as a big one in the space of this. Cache as a service, auth as a service, so things like Auth0 for authentication. Caching, obvious one there is the CDNs and things like that. We don't have to worry about building our own CDN. We just purchase CloudFront or Cloudflare or one of the other options in that space. And function as a service is the one I want to talk about today, which is the code side. So it's your code, it's deployed to the cloud, it runs when needed, and you only pay for it when it's executing. Got lots of execution, it's going to scale up for us. Have next to no application, it's going to scale down again. So it's a very flexible solution for us. What are the use cases for it? How do they work? We've got two main types. We've got synchronous. What do I mean by synchronous? I mean a service that is invoked and provides a response immediately. API is a good example of this. You send a request to your API, you get a response back. Easy. Chatbot, same thing. Alexa skills, stuff like that are all synchronous. The other option is, of course, asynchronous. Here we have actions happening later, usually via some sort of message system or a timed event. Webhooks are a good example. So when your CI system finishes doing its work, you're going to have a webhook sent back to GitHub so that GitHub can display the result of the CI. That's really, really common scenarios. Database changes are another one, or an S3 change, so drop a file into an S3 bucket, do some compute on it, resize the image or whatever you're going to do. All those are asynchronous uses, and serverless is really good for those as well. Obviously, I'm talking to you about serverless, so I think this is a really good thing. I would be selling you snake oil if I didn't tell you what the challenges were. This technology has specific use cases. There are situations when maybe it is not the best solution. There's things you need to be aware of when you are going to be using it. So firstly, you've got to be aware of startup latency. A serverless application doesn't start immediately because it's not running. It has to be started up. We call that the startup latency or the cold start time. We'll talk a little bit more about that later. But if you're doing something like stock trading, maybe it's not ideal for anything that needs to be really, really fast startup. There's also a time limit. Your application cannot run forever. So if you've got an operation that takes 20 minutes, takes an hour and a half, this is not the technology for you, unless you can break it down into discrete units that you can run independently, at which point maybe it is. But under normal circumstances, the average serverless operation runs for less than 5 minutes, and that is enforced by the platforms. State is external. This is a non-issue for PHP developers. We never ever have to worry about this because we've been doing this for 20 years. We never store state between requests in a global variable because that's not how PHP works, and that's not how serverless works. If you're coming from another application runtime language, then maybe life is different over there and you're used to dropping things into a global variable and picking them up on the next request. You can't do that in serverless. As I say, not a big one for us in the PHP world. It's also a different way of thinking. Serverless applications tend to decompose their systems down into finite groupings. You tend to think in smaller blocks of compute, and you tend to think in terms of events. This happened, therefore I want to run that code or do this operation as a result of that thing happening. So you've got to think slightly differently if you're going to build a fully serverless application. But for me, the most important thing is the value. I had a conversation with Bo a little while ago, but I think he nailed it in his final point here. We're relearning something that was known in the timeshare days. Pricing needs to be based on something that customers value, not infrastructure. And I think that's really important. Your customers do not care about the cost of running the server. They care about the profits and the benefits of their application and what the application can do for them. And serverless is a step to more closely aligning the work done in the application with the amount of money you are paying. And I think that is quite powerful. So when should you use serverless? How are you going to get into using serverless in your day-to-day world? Some of the obvious cases are going to be things like responding to webhooks. So if you're building up an application and it's already in place and then there's a need to start adding some webhook responses, consider putting them into a serverless environment. They're nicely isolated from the rest of your application, so it might be a really good place to start. Similarly, if you're building some static websites or PWA type application, then when you need to do a little bit of compute in the server side, then a serverless action works really well. Maybe processing a contact form or something like that. Really good use case for serverless. And additional features. You have your current platform, it's working really well. You need to add a new feature. Look at whether it would work well on serverless. Maybe this is the point where adding some serverless actions is the way forward for adding that new feature to your current app. Variable traffic levels. If you've got bursty applications, then serverless works really well. And similarly, if you have an application that changes and needs to scale with cost, i.e. you don't be spending money unless you have the traffic, serverless works really well for that as well. Certainly worth considering. And I hope to show you more about that as we go through. Serverless is everywhere. The big four, Azure, Google Cloud, AWS, IBM Cloud, they all have a serverless function, a serverless thing they're prepared to sell you. In the open source world, there are multiple choices as well. So I've got 3 listed here from left to right. We have FN, we have Apache OpenWhisk, and we have the OpenFaz system. All open source, all good choices as well. If you want to do PHP, then these are the ones you should be looking at first. Much easier on these platforms. So on the open source side, OpenFaz and OpenWhisk have got great first-class PHP support. IBM Cloud's function system is built upon Apache OpenWhisk, so that also has great first-class support. AWS went a slightly different way. So Python and JavaScript are their key native choices, but then they built a system that allowed for pretty much any other language to join the party. And that's a really neat solution, and PHP works really well on AWS as well if you use their runtime layer system. So that would also be a perfectly viable choice for doing serverless in PHP. As far as Azure and Google Cloud Platform is concerned, they are not so good at PHP from what I can tell. Happy to learn otherwise, but they don't seem to be on the same train. Let's talk about Apache OpenWhisk. I've got to admit a little bit of bias here. I am a member of the Apache OpenWhisk project. I am responsible for the PHP runtime within Apache OpenWhisk. So yes, clearly slightly biased here. I think it's quite good. I like open source. I like PHP. I like serverless. This seemed like a good way to contribute to the greater ecosystem. So I contributed PHP runtime to OpenWhisk, and I think it works quite well. Obviously, you can see the source code, so you can go and decide whether you think I've done a reasonable job or not. One of the really nice things though is that we can talk about OpenWhisk because we know how it works and we can look at it. So let's quickly go through how OpenWhisk works and talk through how I've used it. All serverless systems work basically the same way. So here we have the basic operations. We have the concept of sources that trigger events. So things like our webhooks or our S3 buckets or our API calls or our skills or whatever they might be. They all result in triggers that come into our actions. Our actions are all independent to one another. They can be written in multiple languages and they will generate our results. It's the fundamentals of how this system works. Talk about OpenWhisk. OpenWhisk is very language agnostic. JavaScript, Python, Ruby, Java, Go, whatever, .NET Core, Swift, PHP, they're all here. And even Docker, so you can run whichever language you like. If you want to write Perl in OpenWhisk, you can do. Today, we're interested in PHP, so let's talk about that one. We'll start with the basics. Hello world. It's where we always start with the new technology, isn't it? So how do we do hello world in PHP? It's a simple function. Three main things of interest here. The function is called main. We call this our entry point in the OpenWhisk world, and it takes a set of arguments. These are your event parameters. The event parameters are everything you need to know about the outside world in order to run your operations. So this is how you learn about which particular things you need to do. They all come in your event parameters. You then go do your work, and then you need to return a result. We call that result the service result. And it's an array of key value pairs. So nothing particularly complicated going on here. You can write that sort of code in your sleep. To get this onto OpenWhisk, we use a command line tool, WSK, which is pronounced whisk. I know what you're thinking. It's pronounced whisk. Why couldn't they spell it properly? I don't know. I have no clue. Apparently vowels were in short supply when we wrote this command line. Whisk action update. Hello is the name of the action. Hello.php is the source code we would like to be executed when the hello action is run. And we fire that off, and Apache OpenWhisk will run take that source code and store it for us, and we're done. We can then run the action by using whisk action invoke. You notice that we're using the word invoke. We talk about invoking our actions or invocations. Just different terminology to mean execute or run, because clearly we need more than one word to say the same thing in technology. So we're invoking our actions here. -- result on the end tells the OpenWhisk system that we would like a synchronous execution here, please. So we'd like the result sent straight back to us. And here you can see that we've got back the message with hello world straight away, nice and easy. And it looks JSON-like by the time it hits us. How did it do that? So I said OpenWhisk is open source. As a result, we can look behind the scenes at it and see how it actually works. Look at the source code. If you want to look at the source code, you're going to have to know a little bit of Scala. But this is the fundamentals of what's going on behind the scenes. In OpenWhisk, we have Nginx at the front end. So everything comes into OpenWhisk as an HTTP API call of some form or another. So although we use a Whisk command line tool, behind the scenes that became a standard HTTP API call and hits our Nginx. We then hit the controller. The controller is where all the clever OpenWhisk stuff is. That will use service discovery with something like console in order to do its work. Persistence in CouchDB, so that we're going to store anything into there. We're going to use Kafka for queues so that we can manage our operations. And then we have an invoker that will deal with actually running and marshalling our action containers. The action containers are where our source code is going to run, and they're individual ones for each runtime, for each language, and for each action. This is when we go create an action. Whisk action create hello.php results in a post request that hits the controller. The controller will store the PHP code that we have uploaded into the CouchDB and send back an OK. It does nothing else. It doesn't validate it, it doesn't check it in any way whatsoever. It just drops it straight into CouchDB. So when we invoke the action, we start caring about whether this code is valid and whether it's any good. So this is a process of invocation. Again, it's a post request into the controller, and the controller will send an invoke message through to the invoker. The invoker is going to get the source code out of CouchDB, and it is going to create and instantiate an action container for this action. It will then send that source code into the action by using a post API call to the action container on the /init endpoint. Once the action container has the code, it will then run it using the /run endpoint. So the invoker can run the action more than one time. Once the action has run, the results are sent back to the invoker. The invoker will store them in CouchDB along with any logs and then send the result back down to the controller if it is a synchronous action invocation. That's it. That's how we invoke an action. This is what the container lifecycle looks like. So these containers are simply Docker containers. They host the user written code. So each container is independent of all the other containers. We don't risk any sort of contamination here. The invoker is going to start our container up, and now it starts running, and then it instantiates with a poster /init. Once we've got an instantiated container, we can post /run as often as we like. So the key thing we've got going on here is that we have multiple opportunities to run the action code. So if you need to copy this action 1,000 times in quick succession, then we can reuse the same container multiple times, and we spin up more containers if we need them, but we can reuse the same one more than once. But the very first time we run that code, we have to get the container going, we have to drop the code into that container. So there's that startup latency that I was talking about before. We call that the cold start time. So you can see where that time comes from. We're cold, and we've got a concept of warm start time where we already have the action container running and we just need to run the code once again. And then once we've finished, we've not run this action code for a little while, which is defined by the platform, then we will delete this container completely and it is gone. That's it. That's the fundamentals of how it works. They all work basically the same. So this was OpenWhisk, but you'll discover that Lambda or Azure's functions or Google Cloud functions will all work fundamentally the same way. It all gets way more interesting though when we start talking about APIs. So how do we do APIs? Let's start with OpenWhisk. For an OpenWhisk API, we can simply add the --web flag to the action update command, or the action create, it's the same thing. If we do that, we now turn this action into what we call a web enabled action. So it gets a public facing web address. Looks something like this. We can hit it with an HTTP client, pick your poison there. Personally, I like curl. Postman is also very popular, I understand. So we hit curl against our action and we're going to get the response back as we would expect. And there we go, it's JSON response. Not the most pretty URL. It's defined by the platform. So I ran this one on IBM Cloud. So the openwhisk.ng.bluemix.net is the domain name they're using. Great for webhooks, great for Alexa skills. Not so good for public facing APIs for your clients. If you're going to be using this for public facing APIs, use an API gateway. Again, all the platforms have got their own API gateways. It doesn't matter which one you're using, they've all got one that looks vaguely similar. Enables you to do more with your endpoint. You can route different methods on the same endpoint to different actions, which is incredibly powerful. We can have custom domains. We can rate limit. We can have security with OAuth cores, API keys, whatever. We can do analytics and stuff like that, all done by this component called the API gateway, which sits between us and our OpenWhisk or our serverless system. In OpenWhisk, it's part of the Whisk command line client. So Whisk API create enables us to create an endpoint. In this case, I'm creating a group called /demo, and then this is the hello endpoint within that group. I want it to be on a GET request. So, and then the action hello will run. And again, simple code to actually call it. Takes command query parameters, so I can pass in $name equals Rob, and I'll get back hello Rob as my JSON reply. All very easy and suitable for giving to customers. Let's look at a case study. Serverless API written in OpenWhisk. Nice simple one that I did to play around with it. To do backend. I don't know if you've heard of to do backend, but this is a project which enables you to compare multiple implementations of the same API. So it's a simple to do system, so you can add to dos, remove to dos, things like that. And it's got a full test suite, so you can tell whether your implementation actually matches the requirements. And there's a sister project called To Do Frontend, where you can compare multiple implementations of a front-end application, a GUI type application that talks to this API. So in theory, you could get one implementation of To Do Frontend, one implementations of To Do Backend, and you've got a working To Do application, and you can mix and match. So it's quite an interesting project to look at and a good one to play with. So this is how I did it in OpenWhisk. So PHP implementation, I decided that we needed 4 actions to handle this. Persistence, I picked PostgreSQL. It seemed like a good choice. I haven't played with Postgres for a while, so that was cool. API gateway at the front end, so my clients hit the API gateway. Depending upon the endpoint they're hitting, we're going to hit one of the 4 actions, which will use the Postgres for the actual work. How are we going to do this? How are we going to manage 4 different applications? Clearly, we're not going to be using Whisk action update every time. It's going to get tedious, it's error prone. So we're going to use an infrastructure system. Infrastructure as code it's known as, and the one I've picked is Serverless Framework. This is quite a popular one in the serverless world. The name's a little bit unfortunate. The word serverless is already used in way too many places. So this one is Serverless Framework, just to confuse us. It exists in order for us to describe the shape of our application, and then Serverless Framework will configure up the platform with what we have set up. So this is done via Serverless YAML. So here we have a service, which is OW to do backend. So I've given it a name to my application. It's an OpenWhisk in PHP. And then I can configure my actions themselves. So here's an example of one of them. So here we have edit to do. That's the name of the action. I want it to run the edit to do PHP file, which contains a main function. And I can then go through those, and then I can set up an event. So the events are the way that we can trigger our actions or our functions. In this case, I want an HTTP event, which means I need to use the API gateway, and Serverless Framework will automatically configure the API gateway for me. The path is going to be obviously the URL that it's going to hit, so /to/do/id, and I want it to be a patch on the HTTP method in order to edit this particular to do. So I will then create other representations inside my serverless.yaml for all the other actions required for this API. Project files. Seen all about the serverless YAML that goes in my root folder. I'm going to have a source folder for my source code, and then I'm going to use Composer, because that's how we do things in PHP nowadays, to handle all my dependencies. So it's looking like a fairly normal PHP project at this point. Here's my source. I have a namespace called to do, where I'm going to put all my domain logic. So I've got an entity called a to do. I've got a mapper and I've got a transformer. So all my domain logic is living inside my to do namespace, auto load via Composer. And then I've got my actions in a separate folder where I've got add to do, delete, edit, etc. all sitting there. And finally, I'm going to use some DI on this project, so I've got my container as well. So just standard PHP at this point. Edit to do looks something like that. And I appreciate that even though we're online, that text is too small to read. So let's bring it up into fairly big and look at it in turn. Start with the outer side. So here's our main function. And clearly we've got to do some error handling. So we're going to do some stuff and we're going to wrap the whole thing in a try catch, pick up the error, and we can just dump the error out. The reason we can dump the error out is that we're in a serverless environment. We're not in a standard PHP web environment. So anything written to standard out or standard error is stored in the logs. Because it's a Docker container, anything goes standard out, just goes straight into the logs. So that's quite simple. Anytime we want stuff in the logs, just echo it or var dump it or print r it. You can use error log as well. They will all work, get things into the logs. This is an error situation, so we're going to return our status code. Status code is going to be somewhere between 400 and 500-ish, something like that. And then we're going to enter out our body with our actual error message from the code. What we're returning is what goes back down the wire to our client. Yeah, about the actual work itself. Firstly, we're going to have to extract stuff from the event parameters, that arguments parameter that comes into main. Firstly, we can explode the path. So if we explode on underscore OW underscore path, we're going to get all the parts of the URL. If you remember, we defined this one as /todo/ID. So ID will be the last part of the path. So we can just array pop it off the end of the parts, and we now have the ID. OW body contains the body of the patch request in this case, or a post request if we're doing a post. It's going to be base64 encoded, so we'll need to decode it, and then we'll need to JSON decode it as well, because we actually want the data itself and we're expecting a JSON input. And obviously we're going to throw an exception if there's a problem. So if we don't have the right data, we're going to throw an exception. That will get caught by our error handler we wrote earlier. So that's how we handle input. Next stage is to do some work. Grab our container, and then we can grab our mapper from the container. Because we've grabbed our mapper from the container will worry about setting up the database connection for us, as it would in any DI situation. Then we can load the to-do up, from the mapper, update it with the data, and store it back into the database. So some sort of operational work is done in each action. And then finally, we need to output the data. Just because we're in an API situation doesn't mean that we can just throw out anything. We can't just grab whatever's in our database and throw it down the wire to our clients. That's just not the way to be doing this stuff. The way to do this stuff is to have a view layer, have a presentation layer, same as you would for an HTML website. I've chosen to use a system called Fractal, which is a a transformation system from the PHP League people. And what it will do is it will create a representation of our data in a format suitable for going down the wire, nicely sorted out for us. So I grab the transformer, I create a resource object, which is a fractal thing, and that will know how to actually create my data from my to-do item, which will then be able to send down the line. And I can use toArray to get the representation out for me, because OpenWhisk will turn it into JSON automatically for me. And that's the code involved. So we have got to deal with our input. We dealt with our central bit where we did the actual work. And then we dealt with our view layer where we created some nice presentation. We can deploy it using the serverless framework. The command line tool for that is called Serverless. They've also got a short form called SLS. And that will go away and send all the data up to OpenWhisk for me. And once I've done all that, I now have a working API and I'm done. So that's basically how it all works. So we now know everything there is to know about how serverless works. Talk about Amazon. I could be wrong, but I'm willing to bet that of all the people in the audience, more of you have used AWS than you've used IBM Cloud. You've probably heard of Lambda. Lambda was the people who started this whole thing off. The Lambda product was introduced in 2014. That was when this round of serverless functionality really took off. So let's look at how to do that in PHP. It's only been sensibly possible since 2018, which is when Amazon introduced the concept of runtime layers into the Lambda system. And the way you work it is that you create a layer, it's got the PHP executable in it, it's got a bootstrap script, and then you can write your PHP function and you're off to the races. It's a bit boring and a bit tedious to create that layer and the bootstrap script and keep it all up to date. And fundamentally, we all want the same set of layers. What happens in that sort of situation? In that sort of situation, someone steps up from the community and builds a project. And that project is called Breath. It's written by a guy called Matthew Napoli. It is awesome. It is a wonderful piece of technology. Lovely, lovely project. It does all the work to make running a PHP serverless action within AWS simple. Fortunately, it also uses serverless framework, so that makes life nice and easy. Orchestration is easy and very, very handily. It has really good documentation as well, as all good open source projects should have. So let's look at Hello World within Breath. Looks slightly different from the OpenWhisk one, but looks remarkably similar to how you would do a Lambda within Node.js, for instance, or something like that. Key things here is we're using the auto load from Composer. So again, it's a Composer project. And then we create a anonymous function, a Lambda, which takes our event. Now the event again is the parameters that represent this particular invocation of the action in a similar way to the arguments from OpenWhisk. And then we can return whatever we need to return from our function. And it will go back down into the Lambda system. Very, very similar in that sense. Serverless.yaml, we've covered this before. So here we have a way that we're going to orchestrate and deploy our application. Got a name called Hello App. We're going to set the runtime on to provided, which is the terminology that means we're going to provide a layer and then we have to list our layers. In this case, I picked PHP 7.3. Then I've got my action called hello, and the handler is going to be index.php, which is where my closure lives. And again, deploy works exactly the same way as before, and we end up with a function on Lambda. Run it using the serverless framework. So serverless invoke -f hello, f a function, will result in hello world coming back to us. And we can quite easily pass in some data like name of Rob, and we'll get back hello Rob. Nice, quick, simple, and easy. One of the really cool things about Breath and the Lambda system is that you can all run it locally as well. So we can run it in Docker. If I do serverless invoke local -- Docker, I now run in the hello function within my own local Docker. Again, it's going to run and whir and click, and it will bring up my hello world. And Xdebug works. If you need to debug, you need to do step-by-step debugging. You can do it in the local Docker for this serverless action. So you're not giving up all the comfort and the abilities that you have in PHP development just because you're running inside Lambda. Breath is awesome. Going back to the APIs, going to add a API gateway. To do that for AWS is exactly the same as we did it for OpenWhisk. All we have to do is add an event section with an HTTP. And here I'm setting up two different endpoints, /hello and /hi/name. Braces around them creates a placeholder which will become the parameter within my function. So exactly the same way as before. And this is one of the benefits of using the serverless framework for our orchestration and infrastructure as a code platform, in that we only need to learn one technology and it works across multiple providers. Because we're in the API context, we want to return HTTP. To do that within Bref, we leverage the PSRs 15 and PSR 7. So in order to write a function or an action inside Lambda for a HTTP API, we simply implement a request handler. That's a very standard interface. As I say, it's from the Fig. The function is called handle, and we do our work, and then we return a PSR 7 response, which we can have status code, we can have the headers, and then we can have our data. And here I've JSON encoded it because I've chosen to do so. Deploy, same as before, but you'll notice that we get an endpoint called L1v6 whatever. Again, not the nicest of endpoints, but we can actually override that because it's HTTP. Sorry, it's an API gateway, so we can actually put in our own domain name too. Test it, use curl or Postman if you must, and you'll get back the response. So let's look at another case study. Here is a Project 365, my photo a day website. I'm a photographer. I don't know if you realize this. If you've been following me at all, you'll probably be well aware that I do quite a lot of photography. I take a photo every single day. I've been doing this since about 2013. It's a way to document my life, to keep track of what's going on. It helps me remember. It's my way of diarying. And I decided I wanted a website that had just those photos on it, because at the moment they all live in Flickr along with all the other photos I take. So I needed a static website to display just my photo a day pictures for this particular year. It's a serverless application, so it's going to be hosted on S3. We're going to put CloudFront in front of it because that's going to allow us to put an SSL certificate on it. We're going to put our domain name there. We're going to have it nice and fast all over the world. And then we're going to use a Lambda PHP function in order to update our static website with the new photos that as I create my new photos each day. So this is my project. And this is the architecture for the Lambda function. This function is an asynchronous function. It runs on a cron tick, on a scheduled task. Every few hours it runs. It goes to Flickr, picks up any new images that might exist for this particular year. It will then create the new HTML for the web page. It will store it into the S3 bucket, and then it will invalidate the CloudFront cache so that everyone can see my new wonderful pictures. So 3-step process essentially, maybe 4 if you include building the HTML up. Very, very good use of a Lambda function this. Use serverless framework, so our function is going to be called update. It's going to go to the index.php, and our event this time is a schedule. So I have to give it a name and I have to give it a rate, and this is set to run every 2 hours. So there's no API gateway in this case. I don't need to hit this from the web. It's not public facing in that sense. Here's my main function. There's quite a lot of code there, but the fundamentals are very similar. Here we've got the year, so we're extracting from the event data the year that I wish to build my web page for, which will default to this year. Then I have some other code. The rest of my code is in other classes because I'm still building an application in PHP. I'm still building separate classes for my actual domain logic. All my business logic is somewhere else. I have a photo page creator. This photo page creator will go and get the data from Flickr and build the HTML web page. Once I've got the HTML, I can then use the uploader class. The uploader class will upload one to the S3 bucket, so upload the HTML to the S3 bucket for a given year, and then it will invalidate the cache, and then the work is done. How do we do all that work? Fetching photos from Flickr is an API call. So I'm running inside Lambda and make an API call over to Flickr. Flickr's API looks something like this, where we're going to have to build a rather complicated set of parameters onto a query string, and then we can call Guzzle. Guzzle is already available to us because it's used by Bref, so that makes life easier. And then I can decode the body from Flickr, and I've got my photos that I need to iterate over and build my HTML. I'm not going to show you how I build the HTML because, let's face it, I'm an API developer. My HTML is a bit ropey. You don't want to see it. Let's just put it like that. Upload into S3. We're in the Amazon ecosystem, so we use the Amazon PHP SDK. Again, that's available to us as part of Bref, but we can include it anyway. And we put it in our composer JSON, so just in case Bref changes anything, not a problem, because we have our own copy from within, our own reference rather, within Composer. All within the AWS ecosystem means that the credentials just work. So I can instantiate a new S3 client, and because I'm running within the context of Lambda, the credentials that are being used to run the Lambda will automatically be picked up for running the S3 client, which makes my life easier. If I wanted to use different credentials, I could pass them into this constructor here. I don't. The ones I've got are currently fine. And then put object is the S3 action in order to create or update my data within the S3 bucket. Finally, I can invalidate the CloudFront. CloudFront client is another Amazon SDK thing, works exactly the same way, so that's nice and easy. And then we call create invalidation in order to tell CloudFront that the current copy of this page is out of date. There's a new one. Update the paths. I only need to update this 1 year file because that's the only file that's changed. And then I get a result. And here we are. We've got the finished website. This is a picture from a little while ago, but it's a particularly nice one of my link amiibo, so that's the one I picked. So there you have it. What we have done is we've got a complete application in Lambda that does exactly what I need it to do, and I have my website out there showing just the photos I need. Hopefully, you've been able to see everything there is to know, at this level at least, about how serverless works. We've looked at the way serverless is small invocations of code that run when needed. We looked at how we can use an infrastructure as a code service, such as serverless framework, in order to orchestrate many different actions and treat them as a single application. So I can write an application in my desktop environment where I'm building multiple actions. I've got different things involved, like my S3 stuff, and I've got my buckets for that, and I've got my CloudFront definitions. I can define all that within my project and send it all up to be deployed onto my staging environment or onto my live environment without any problems, just by using infrastructure as a service. In terms of PHP, it is great as a serverless language. It works really, really well. We're already used to stateless coding. We're already used to the idea of set up and tear down at the end of each request. It fits the serverless model really, really well. And I think you should seriously consider it for your future work. And I think that's it. So let's wrap up at this point. A few resources for finishing off with. If you want to know more about me, acrobat.com. If you want to know more about serverless, that Martin Fowler article is really, really good. The two different case studies that I talked through today are both on my GitHub. And then also openwhisk.com, Lambda's website, and Bref's website are also there. And with that, I wish to say thank you very much.
We're on, great. So thank you very much for your talk, Rob. And we've got some questions. And first of all, Rob, it's really a big event that you joined our conference. You've never been here offline, I mean, at least at our conference, but we hope that when pandemic ends, everything will stabilize. You still want want to visit Kiev and our conference, and we would be really glad to see you personally here.
Yes, I would love to go.
Great. So Q&A time.
Okay, so yeah, probably we can start. And the first question is, why Google platform is not so good for PHP, in your opinion? Why it's not so prepared?
Right, in the context of serverless in particular, so Google platform itself, fine for the rest of it, but serverless itself, they don't do PHP as a native runtime, and they've got some preview thing that's currently in beta. I don't know a lot about it, but when I looked at it, it required you to know some Docker stuff. The point of serverless to me is I don't have to worry about the infrastructure. And if I have to worry about Docker, I'm worrying about the infrastructure. So it looks like Google are going the same way that AWS did with Lambda, and some sort of layers on top or runtimes on top. And if they're going to go that way, we will need a project like Breath that will abstract all that away from the normal developer, because we shouldn't have to worry about that. I shouldn't have to care about my Google application engine Docker stuff. You can tell I know nothing about it whatsoever. I don't want to know anything about it. And I think the Google serverless system will become quite good for PHP developers if they provide tooling around it that looks far more like the solution that Breath has done for Lambda.
Okay, yes, thank you. Another one, does it make sense to use a serverless approach with PHP on bare metal servers, and which you are usually pay once?
That depends, doesn't it? So production-wise, if you've got your own servers already, then you're probably, if you go run serverless on your own production servers, then you're probably quite a big organization. That classic term enterprise, something like that. And if you're in that situation, then maybe it helps as a way of utilizing your bare metal servers efficiently, particularly if you've got lots of relatively small functions of compute that you need to scale independently of each other, then something like that might make a lot of sense. At that point, you'd also be looking at something like Kubernetes as a solution as well to do that, and let the orchestration within Kubernetes solve that basic problem too. Maybe. It's beyond my pay scale. I don't have that sort of world that I live in. So for me, the fact that it runs on public cloud is where it gets most interesting, because I'm not paying anywhere near the same sort of money, and that's where it gets way more cost effective from my point of view. So yeah, possibly.
Okay, and probably another one question from the economics side. So are the costs of serverless approach competitive when it comes to some Highload, a lot of requests and so on?
Right, it depends. It's a short answer. Serverless is particularly cost effective for bursty loads. So if your server utilization is over 75%, 80% utilization 24/7, then it's almost certainly cheaper not to use serverless, certainly not on public cloud. If your server utilization drops overnight, for instance, then you're in a different ballpark, and then it starts looking remarkably competitive. If you need, one of the other things about serverless is you've probably decomposed your application down far better. So you're probably not wasting resources on scaled up servers that you're not using the resource, you don't need the compute for, because you've probably better compartmentalized it. But that's not a feature necessarily that you can't do outside of serverless. It's just that you're kind of enforced to with serverless. So as you get closer and closer to 100% utilization of your server, then it becomes more and more cost effective to use something else other than serverless. And you start having to do the numbers to work out what's wise. But you still get the auto scaling, you still get the fact you don't have to manage them yourself. All those features are worth something as well. So maybe you want to do it just to get rid of a whole load of stuff you don't want to be doing. And that's worth something in terms of DevOps salaries or sysadmin salaries or support costs or whatever you might also have to pay. So it's not a clear-cut answer, but there's definitely points where you start looking at other options as well.
Okay, I see. Another one question is OpenWhisk PHP support looks better than AWS Lambda plus Bref. Is it so?
How can I answer that? I wrote the PHP support for OpenWhisk. Obviously, it's really good because I wrote it, so I think it's good anyway. The nice thing about OpenWhisk and the OpenWhisk PHP support is that it is a first-class citizen there compared to Node.js or compared to Go, compared to Python, compared to every other language that OpenWhisk supports. PHP is at the same level. It's completely and utterly first class. It works exactly the same way internally. On the Lambda side of things, runtime layers are not the same as AWS's native runtime support for Node and for Python. And maybe they've got Go now, I'm not sure. Maybe they've got Java. So we are, with PHP in AWS, we are a slightly different world. But the way they've done it with the runtime layers is quite elegant. And it's not that much removed from the way the native ones work anyway. So whilst I think the OpenWhisk one is neater, I say partly because I wrote it, the AWS one, particularly using Bref, is not a bad solution at all.
Thank you. And one more question. It seems like serverless can kill traditional frameworks like Symfony, Laravel, Yi, and so on, with this routing, cross-request caching, and so on. So in serverless, we just only need libraries, don't we?
Yeah, exactly. So one of the things about going to a serverless world is that you have to start thinking slightly differently. With the API gateway, you can do all your routing inside the API gateway, and then you're only writing your serverless actions. And your serverless actions start looking a bit like controller actions from a traditional PHP framework. Now, something like Bref will do an entire monolithic application within a serverless action, but that's not particularly an efficient way of doing it, but it's quite a good way to move an application up to learn about what's going on. So yeah, there's a fairly strong argument that you don't need the routing layer, at least, of a traditional framework within a serverless environment. So I'm involved quite a lot with the Slim framework project, for instance, and Slim isn't needed in serverless whatsoever. The other parts of the traditional big frameworks, like your database layer, stuff like that, may certainly be used. And I do have applications where I've got things like Eloquent in use, because I still need to write a real application, a real PHP application within my serverless action, but I don't need the front end side of things anywhere near so much.
Okay, and another question, which might be quite opposite to this. Can you suggest any good example possible to work without serverless?
And what can't you run serverless with? There aren't many. It comes down to those constraints and challenges I talked about earlier. The key ones are related to latency and startup more than anything else. So if it's a real problem that you have that startup latency, then this is probably not the ideal place to be looking. High utilization areas, again, that's another area where you might not want to necessarily run straight to serverless because it's possibly more cost efficient to be somewhere else. But there aren't that many long running applications. If you're going to write a application that takes 50 to 60 minutes to do its processing, you can't do that in serverless. The serverless system will kill your runtime. So that's an obvious one. A long running process definitely is not suitable. But there aren't that many. The main problem is trying to motivate yourself to rethink how you think about serverless in the first place.
Okay, and so I see that the last question was about quite opposite. So I maybe just asked it wrong. So and what we can do with serverless? So very efficiently and better than in a usual approach.
Anything bursty. Anything bursty that you need to automatically scale up quickly. So one of my clients is an insurance company that does renewals once a month. So we do 29 days of nothing. And then we do 6 hours where we need to get 200,000 emails out and having processed 200,000 renewals. So we burst out really, really quickly for 6 hours. The system automatically scales out to multiple multiple actions. I don't have to worry about any of that. The minute I finish doing all my renewals, the serverless system automatically collapses down all those instances for me. I don't pay anything that I'm not actually doing. So anything bursty, it's really, really good.
Okay, that's great. And probably the last one at the moment. The question is, I wanted to know about the fate of Zen framework. What and why Laminas? And what can you say after these years?
Right.
Yeah.
Yeah, I've been involved with Zen framework since 2006. I've been doing Zen framework an awful long while. The Zen framework is owned. Obviously, the trademark of Zen framework, the trademark for Expressive, were owned by Zend. Zend was bought by Roguewave. Roguewave was then bought by Perforce. And during all that, they decided to make it its own independent, completely independent of Perforce's framework. However, from a legal point of view in the United States of America, and legal stuff in the United States of America is a unique beast, I think is one way to put it. They are very weird over there. It was found that it was problematic to take the Zen framework and the Expressive trademarks and give them to an open source foundation. And in order to move the framework forward, move the project forward, make it completely self-independent, it was easier to change the name and take the hit of a name change than to deal with the legal problems in the United States of America. Somehow that doesn't surprise me. What can you do? Laminas is fine. I quite like Mezio. I think Mezio is quite a nice name for the framework, the micro framework. They're just name changes. The project itself is the same project. It's the same code. It's the same people behind it, and it's still good.
Okay. Well, I think that we are running out of the questions at the moment. Okay. So, yeah, we can stop at this point. Thank you very much.
You're very welcome.
It was a great Q&A session, actually. And I must admit, Rob, that you have quite a massive collection of PHP elephants. How many years did it take you to collect it?
Oh, those go back many years, don't they? So the yellow one over there, sit with my hand. Can you see that? Oh, no, you can't see that because...
no, I think you could move the camera, yes, because...
Can I do that?
Wow.
There we go. Haha. There we go. Where's my hand? There's my hand. So the yellow one there is the newest one from Sunshine PHP this year? No, last year. Then the green one is from Zen Framework a few years ago, PHP Women. The pink one and the blue one are the originals, which I got back in 2007-ish, 2008, something like that. And then the one at the front is the rainbow one, which is the diversity elephant, which was about 3 or 4 years ago from Mark Baker. I like them. They look good. And it creates quite a nice backdrop.
Wow. Really impressive. Okay, thank you once again. It was a talk of Rob Allen,